So, hello everyone and welcome back to the channel. Today, we will go through a complete optimized solution to count trapezoids formed by the points on a plane. I will explain the code line by line so you can easily follow and reproduce this approach in interviews. So, let's dive into the problem. Okay, so in line number 1, from collection import default dict. Here, what we have to do, like import default dict from the collection module. And why? Because default dict make it easier to group and count items without checking whether keys already exist. Like we use several nested default dictionary letter for grouping. Okay. In next line, class solution def count trapezoids self comma points. Here we define a class solution with a method count trapezoids self comma points. Okay. And why? Because standard Leetcode style class method wrapper point is a list of x comma y pair. So in line number 5 to 7 we have compute number of points and early return when fewer than 4 point exist. You need at least 4 distinct point to form any quadrilateral or what trapezoids. Okay, like complexity not what 0 1. In line number 9 to yes, in line number 9 to 14 we have a helper function to compute GCD A comma B using the Euclidean algorithm because we need to normalize direction vector to integer pairs. Some environments might not allow maths.gcd. Like we have to also gotcha. Always take absolute value to ensure the correct GCD sign we have here. Okay. So in line number 16 to 26 here we have normalized a direction vector like dy by dx to a canonical integer representation like dy norm dx norm. Okay, with dx norm is greater than equal to 0, like because to unordered pair that lie on the same line segment should map to the same direction key. This makes direction comparisons robust and integers based, like no floats. Okay. Also, a edge case is there that vertical lines are 1 0 here and horizontal lines are 0 comma 1. Okay. Like for normalization flips, sign if dx is a negative to enforce a consistent orientation. Here the complexity means what? 0 log mean mod of dx and mod of dy for GCD. In line number 28 to 28 to yes 40 no oh 40 yes we can also explain yes 41. Here we viewed a nested dictionary slope lines like mapping yes is intersect set of points and indices on that particular line. For each unordered pair I comma z, compute s is equal to norm direct dy by dx. So compute intercept is equal to a into x1 minus b into y1 for a normalized direction a comma b. This value is constant for point on the same line with that direction, that is integers representation of that line identity. So use a set of collect point indices that lies on the same geometrical line, that is parallel group plus intercept. Why? Because we want to know how many points are on each distinct parallel line for each slope, so that will enable combinatorial counting later. Okay, like here the complexity is what? Outer double loop like 0 n square for each insertion into dict set is average 0 1. In line number uh, 43 to, yes, 43 to 44. Here helper to compute c x comma 2, that is number of unordered pair from x items. Here we frequently need combination of 2 points from a line. Choose 2 points from C point. In line number in line number 46 to 55. Here we compute T, the total number of candidate quadrilateral counted by slope where the two opposite sides are parallel with that slope. And why? Because for each slope, yes, there are multiple distinct parallel lines like different intercepts. Okay, so for each line with C points, number of segment on that line is T is equal to what? C2 means C for each for two different lines with Ti and Tj segments. Every pair of segments form a quadrilateral with those opposite side parallels. So number of such quadrilateral for that slope is sum I is less than j and Ti into Tj. Okay, so line number yes, so like line number from the why the like compute some I is less than j and Ti into Tj efficiently using what? S is s to the power 2 minus some t I to the power 2 by 2, where s is equal to what? Some ti. Okay, so why this count? Because this count all quadrilateral that have at least one pair of opposite side of parallel in direction. Yes, also a parallelogram get counted in the two slopes, once per slope. Okay, so the here complexity is what? 0m. To compute t list, like it is like overall still like 0 and a square dominated by what? Pair generation. Now on the line number, wait, so line number 57 to what? 57, yes, 57 to 57 to what? 57 to, yes, total number of points. So mhm. Yes, so line number 57 to 60. Here prepare to count parallelogram via midpoints. In mid total mat, we'll count how many unordered points where share the same midpoint mid. Like mid direct count what? Count how many of those pair have the same direction decay. Okay, and why parity midpoint? Like in parallelogram diagonal bisect each other, so both unordered pair forming diagonals share the same midpoint. Counting pair of pairs with same midpoint give total parallelogram candidates. So we then remove degenerated case where both pairs are collinear, like which would be for more collinear point, not a parallelogram. So in line number 62 to what? 71. Here for each unordered pair of point I comma j, compute mid, that is x1 plus x2 and y1 plus y2, which uniquely represent midpoint scaled by 2 to a state integer. Okay, so for increment mid total mid, what? Compute d key is equal to what? Norm dir dy by dx, and increment mid dir counts mid d key. Okay, and why a scaled midpoint? Because it uses avoid floats and exact equality problem. Like what is the purpose of that? Because after this loop, mid total mid, number of unordered points pair with that midpoint. So for each mid dr counts partition those pair by their direction to detach collinear pair of pair. And what will be the complexity? That is 0 and a square. Each iteration like what? 0 1. So from line number 73 to 82, here we compute p, the number of valid parallelogram. And what is the expression? Like total counts, that is C2 counts all unordered way to pick those two points pair that share the midpoint. Okay, in line number what? So that is 84 to uh, 84 to like what 86. That is final answer return is t minus p. And why? Because t counted all quadrilateral that have at least one pair of opposite side parallel, but parallelogram were counted twice. Once when using slope 1 and once when using slope 2. So T overcounts parallelogram by exactly one extra copy per parallelogram. So P is the number of parallelogram. So sub- subtracting P yield the correct count of unique trapezoids. So return value is what? An integer is greater than or equal to 0. So the problem is very interesting. It's interesting. Like it can be come in the Google. Okay. So that's it from the today videos. Okay. And this algorithm groups point by line direction and intercept to count parallel opposite side choice combinatorily. Okay. So basically, this problem is very means interesting problem. Okay, you just have to focus and you have to knowledge about the like what means geometry. Okay, so this solution is very efficient, clean, and pass all areas cases. So if you learn something new today, make sure to like the video, drop a comments, and subscribe to the channel for more deep dive explanation like this. Thank you so much for watching. I will see you in the next video. Till then, bye bye. Have a good day.